Hi, good morning. It's been a little while, but I'm back and I'm ready to record more videos. I think it's been a few weeks since my last video, so some people were leaving comments like, are you dead? Are you ever coming back? Is this a dead channel? Have you abandoned us? Short answer is no, I have not. A few things happened since the last time I recorded a video. First thing that I wanted to do was plan out the next few videos. These videos should take a little bit of planning up front just to make sure that we're kind of like nicely segueing the things that we learn from one video into the next. So I wanted to plan out the next few lessons ahead of time and make sure that I knew where I was kind of going with this series. The other thing was that due to a weird series of tech fails / me delivering incorrect information, I had to re-record this video 3 times. I got into the editing stage of the last version of this video and then realized that I had said some things that were actually just incorrect about the engine. So that's not cool. I don't want to give you bad information. So the good news is that I am now a master in today's topic, which is input. So let's get into it. What is input? In game development, input is a general term that we use to describe anything that the player does. So that could be pressing a key on their keyboard, clicking a button on their mouse, but it could also be pressing a button on their controller or even their VR controller if we're building a VR game, or potentially tapping or swiping on the screen if they're playing on a mobile device. Odds are good that if you are building a game, then you want that game to respond to something that the player does. So when the player enters some input, we fire what's called an input event, which captures the result of that input and decides what to do with it. In this way, we can express concepts in the game like when the player presses M, open their minimap, or when the player clicks, fire their weapon. The number one question that people have when they start to build input into their games is, well, okay, where do I put all of this code? I, in theory, know what I want to do in capturing which button presses, and I know what I want them to do, but I'm not sure where to put that. In many written programming languages, and even in some game engines, this is kind of a choice that's up to you. Input can be handled in a lot of different ways and in a lot of different places, and it's kind of up to your creative and best judgment to determine where to put that input code. However, in Unreal, we have a standardized place to put all input events, and that's what we're going to be using today. The place that we record user input events in Unreal 4 is called the player controller. Of course, at this point, you might be thinking, oh, controller, like this? No, not this kind of controller. In order to explain what I mean by a player controller, I'm going to explain some things about the backbone of the way that most games in UE4 are constructed, and hopefully this hierarchy will be useful to you in future tutorials when we try and build off of this, as well as if you want to explore on your own. All UE4 games have something called a game mode, and this game mode is something you can think of as like the spine of your game. It controls a lot of fundamental things about your game, such as what classes we use to determine really basic things like game state, the player controller, and the player pawn, which are 2 things that we'll cover in a second. We will be editing the game mode today, but we'll only be editing it in service of swapping out the player controller and player pawn classes that we're using in our game. If you want to learn more advanced things about what a game mode is and what it does, I will be covering that in future tutorials, especially in the intermediate series, but I'm also going to link some resources down below this video in the meantime if you want to learn more. So as I was saying, fundamentally, underneath the backbone of your UE4 project is something called this game mode. The game mode sits at the very top of the hierarchy. The game mode just sets up a bunch of different classes that contain a bunch of information about the state of your game and really core concepts like which player controller class we want to use and which player pawn class we want to use. So from there, the game mode dictates a player controller, and that player controller controls something called the player pawn. In UE4, the player controller is where we store all of the events that we like to fire whenever the user inputs something into the game. This is a nice, clean, central place for us to write lots of logic around how we should handle all kinds of key presses and what we should do with them. The player controller is also where we might handle a lot of other fundamental things about the game, such as the amount of health that the player has, the amount of ammo that they have, whether the player is alive or dead, which local client the player belongs to, if this is an online game. There's a bunch of different central information that we like to store in the player controller, and generally you can think of it as like the brain of your player. Conversely, there's a second concept in UE4 called the player pawn. You could think of the player pawn as like a dumb flash suit that the player controller can inhabit at will. In fact, we call it possessing a pawn, as though the player controller were a ghost and they were actually possessing just a body for a temporary period of time. This is a useful concept for a variety of reasons. If you treat the player pawn or the physical body like something that's kind of disposable, then for example, in an online PvP game, when your player gets killed by another player, we don't actually have to like lose all of that central logic for a time. The player controller just ejects from the pawn and then goes into a new pawn or generates a new pawn, which is the player's new body when the round restarts or when the player respawns. This is also really helpful for games where you have multiple characters that you control. So your player controller can kind of zip into and out of various pawns, and you take all of that logic with you about how those pawns should control and what we should do with them. But the pawn itself is just like a physical avatar or a body that sits in the world. It's not very smart, and it doesn't really have much logic of its own. So all in all, the stack looks like this. When you start your game mode says, hey, which player controller class should I spawn? I will spawn that player controller class, and then I'll spawn a pawn for that player controller to inhabit. The player controller then tells the pawn what to do, and the pawn carries out whatever the player controller would like it to do. However, if that pawn dies or is destroyed, or maybe the player controller just would like to control a different pawn, the player controller can easily eject from that pawn, move to a different pawn, insert itself, and have all the same access to all the same controls. Up until now, we've been working with the default pawn and player controller that this project that Unreal has released gives us out of the box. Today, we are going to be making a copy of that player controller and that player pawn, and we're going to swap out some of that logic with some logic of our own, just to kind of do it our way. If there are parts of the logic that you want to keep, I'll show you how to keep those things as we go. In today's lesson, we're going to be building a brand new player controller. That player controller is going to be a gardening player controller that controls a gardening player pawn, and then that pawn can plant and destroy flowers at whim. And we're going to be building some lovely, lovely flower programmer art as we go. So let's get started. All right, so here we are, home sweet home, back in our project. I am just going to delete all of this stuff from our last elevator tutorial just to kind of make it cleaner to work in here. If you want to keep all this, you can. If your level looks super different at this point, also cool. This tutorial should work no matter what you have done to your level, provided that you haven't like swapped out the character controller already, in which case maybe this is a moot lesson for you. I'm just going to delete some of these things here just to kind of clear out our space and make it nice and pretty and fresh. So the first thing that we're going to do is we are going to search for and open that game mode that I talked about earlier. So at the top level here under your content, go ahead and type in the filter game mode, and you should find this first person game mode file that has a bunch of different classes listed in it. So remember when I talked about how this is kind of the spine of your game? You have a bunch of different sort of really fundamental properties here. A bunch of these you may not understand or even really need to touch until we get into some of the more advanced concepts in this series. But for now, the two that we care about are, you'll see this player controller class, which is, as it says, the class of player controller to spawn for players logging in. If you're playing a single player game or making a single player game, there's no logging in process. You just start the game. But I think they clarify that this would be the case if you were building a multiplayer game, that when the player logs in with their controller inhabits a pawn. There's this player state class, which is basically how you would replicate information to clients if you are building a multiplayer game. That's something that we might cover in the future. The client server networking model is a very complicated model. If you are just learning to build games, it is going to be the equivalent of handing the keys to a Ferrari to a small child. We will not be doing that for quite a few lessons, but maybe in the future I'll cover some multiplayer networking stuff if that's interesting to you folks. The one that we mostly care about today is this default pawn class. This is the default pawn class that the controller will spawn, and it will be used by players in our game. So we're going to be swapping out this player controller class and this default pawn class today. So let's start with the controller first. This one's really exciting because if you actually go in here and you filter by controller, you will find nothing. This is because the player controller class actually is in C++. There is like a very default vanilla player controller class. If you go back to your first person game mode, you can actually find it here. I think if you hit the little magnifying glass button next to this player controller, it'll show you that it's actually buried in the engine classes folder. This is just the vanilla player controller class. So what we're going to do is we're actually going to build a new player controller just in case we want to add any blueprint events to it, which we do today. But that will inherit automatically from this player controller class. That is the really fundamental vanilla one. So let's do that first. If we go up here to the top level under content, We probably want to make a new folder for this just to kind of make it nice and clean. We can call that player folder perhaps, and just kind of make everything in there so that we know exactly where to access that stuff later. And then what we're going to do is right click here. We're going to create a blueprint class. And that blueprint class is going to be of type player controller. So go ahead and make one of those. And we're going to name that, let's call it tutorial player controller, because we may be building on this in future lessons. Had to take a break to let in my cat. He was meowing at the door. This is Link. Step 2, of course, is that we are going to make a brand new pawn to go with the shiny new controller that we just made. In this case, rather than have you build a totally blank pawn from the ground up, which would probably be a great exercise to follow, but would take a lot of time, what I'm actually going to have you do is just duplicate the pawn that UE4 gives us in this project, and we're going to rip out the things that we don't need. We're going to take all the craft out of it rather than building what we do need. This is, you know, probably some engineers cringing right now, but I love this right now. I'm a big fan of just like copy the thing that's there now and just take out all the stuff you don't want. So let's try that here. If you type in first person character, you are going to probably find that first person character pawn. It should be blue. There should be a little blue line under it, which would make it easy to find. You can right click on that, show in folder view, and find that. It's buried under content, first person BP blueprints. Let's just like go and look at this for a second to see how this is set up and what we might need to get rid of if we are to copy this. So looking at it at a top level, I'm just going to go chunk by chunk and kind of cover what this pawn is doing right now, just so we know which parts of it we want to keep and which parts we want to cut. So this top one, if HMD and motion controllers are enabled, use the VR gun and hide the mesh 2P. HMD is a game dev term for head-mounted device. It is a name that we use for a VR headset. So this is VR code. So because we're not building a VR project in the tutorial series, I am going to cut this right now. If for some reason you are trying to build something in VR, you probably want to keep this. This is what lets you actually control the gun in VR. But when we copy this pawn in a second, we're going to get rid of this in this tutorial. Same with this, reset VR orientation and position. This just makes sure that the headset is set to the appropriate orientation and location when the game starts, or when the user hits the reset VR button. We are not doing that here, so we're probably going to cut that as well. Stick input. You'll notice over here that a bunch of these things in these code blocks are connected to these red input axis, input action. You know, what are these events? We will cover this in a second. Input action is a layer that UE4 gives us to translate an input event, which is a key press, into an action that we would like to perform as a result of that key being pressed. So you'll see here, it just says stick input, but actually you can kind of read over here, it's adding controller yaw and pitch, that's rotation. So what this is doing is this is actually like if I had a controller plugged into the PC and I was using the sticks to control my game, this would be where those events get parsed. So we are going to keep that in case you are doing this tutorial and you need a controller for accessibility purposes, even though sort of building a controller first game is not really necessarily our goal here. Movement input, if using an HMD, movement is based off HMD location. Yes, that's true. There's a little Boolean down here that basically says, hey, do we have a VR headset on right now? We don't have a VR headset on, but that's okay. This is actually just general movement code. This is not specific to VR. There is a condition for if a VR headset is activated, do this other thing. But this is just regular movement code that we do want to keep. This is important. We also see mouse input here. This is when the user moves the mouse around, the camera moves. We want to keep that code. That's good. Jump, self-explanatory. This is, you know, input action jump. We would like to jump or stop jumping. Okay, easy enough. Spawn projectile. This is the last bit. You may want to keep this, you may not. This is your gun. So projectile is a term that we use in game development for anything that moves really, really fast and needs to handle collisions. So most of the time that's a bullet, not always, but a lot of the time that is a bullet. So this is our gun code down here. You may want to keep it, you may not. You'll have the opportunity to keep or discard that in a second. So that kind of covers the pawn. Here to browse back out to that, we're going to right click on it. We're going to duplicate it. We're going to call it tutorial pawn. Again, you can use character or pawn to name your pawns. In a lot of the default UE4 projects, you'll see it called a character. Character and pawn are kind of interchangeable. They mean the same thing. I prefer pawn because it's more technically accurate, but it's kind of up to you. And then from there, what we probably want to do, we made this little player folder before where we actually could put that. So let's find our tutorial pawn and let's just make sure that it's in that player folder with the controller that we made earlier, just so those things are together. And now we're going to go back into that folder, find that pawn, and open that sucker up. Make sure that you are not editing your first person character pawn when we do all this code deletion. You want to make sure that you're editing your tutorial pawn. So if you have this open, you can probably just close it out now just to make sure. And that way, if you ever want to revert back to the old pawn and have all the default functionality, like you mess something up or go too far, you can do that. You will still have that old first person character to revert to. So let's go in here and we're going to delete some stuff. Very exciting. We're going to select all this. It's gone. Bam. We want to keep all of this. And then the gun, we're probably going to get rid of the gun. If you would like to keep the gun, I'm not the UE4 gun police. You can keep it if you want. There are probably some things that we want to get rid of. If we did get rid of the gun, they're just kind of vestigial and we don't really need them. So let's get rid of this VR gun and the VR marker. That's for, as well as this R motion controller, L motion controller. That's all VR stuff. We don't need it. If you look at the viewport, you'll actually see that one of the guns disappeared. That's because it's the gun that only shows up if you're playing in VR. And as well, if you want to get rid of the actual gun, if you're not actually using the gun code, then you can destroy this sphere and this first person FP gun, as well as that mesh 2P, which is like the arm mesh that gets left behind if there's no gun in it. You can get rid of all of that. When you hit compile, something is going to complain. It's going to be this thing that is that's in the construction script, which basically just attaches the gun mesh to the arm mesh when the game starts. It's just a little like kind of snap to joint thing that UE4 is giving us. We don't actually need that, so we can just delete that node, hit compile, and be good. And so now, if we go out to our first person game mode, which we had earlier, and we swap out that player controller for our tutorial player controller, and we swap out the default pawn class for our tutorial pawn, and we hit compile, and we hit play, then we should see a beautiful, clean pawn with no gun walking around in the world. And in fact, there's like another little pawn that is actually in the level by default. You can see it right here. So that leaves its gun behind because there's still one of those in the world. We can actually delete that now. We don't need that in the level. And so you should actually see nothing at all now if you delete that and you move around, because guess what? At runtime, we have a brand new controller and it's spawning a brand new pawn that we just created. So we don't need any of that anymore. Okay, so we've got our controller, we've got our pawn. Just make sure that everything's saved. If you see little gray stars on these two down here, it just means that they haven't been saved. So if you, like, for some reason lose your project or you shut down your computer or something, you will lose the progress that you've made on those things. Just make sure they're saved. We like that. Now what we want to do is we want to add some input events to this controller. So what we're going to do is we are going to learn how to use UE4's input system. So if we back out here to the map, up here at the top, under Edit, you will see, if you scroll down, this project settings, and that will open up a window for you. It will be a very aggressive looking window with many buttons and layers and options. That's okay. We don't care about 98% of this right now. We do care about under engine. If you scroll all the way down, you should be able to find this input button. If for some reason you're working in a newer version of UE4 and it doesn't have this menu or something is moved around, at the top here, if there's a little search bar that says search details, you can also type in input and you should be able to find all of the same stuff. So let's get into that input window. And you will see, number one thing here, a bunch of mappings of input buttons that this project had set up already, probably for that last player pawn. So you'll see things here like jump. It's mapped to spacebar. It's also mapped to the gamepad face button. So that is probably the A button on a lot of controllers. It's also mapped to a bunch of VR headsets, like the L trigger, in Oculus Go, Oculus Touch, Valve Index, ML. There's just a bunch. Oh, ML is Magic Leap, I'm guessing. Okay, so like 80% of this is like for VR controller setups, because you need, every single one of them is a special princess, and it all has its own special input piping. It's very annoying, actually. So but all you need to really care about here is that jump is mapped to spacebar. Great. Fire. This is for the gun that you may or may not still have. The fire is input event is mapped to, or input action rather, is mapped to the left mouse button event. Reset VR. Again, this is for VR. It looks like that's mapped to the R key. So if we were working in VR, we could reset VR with R. Cool. We're not using that, but good to know it's there. Down here, we have a bunch of axis mappings. Axes are any time that you are giving input that could be a value across a particular spectrum. So it's not as simple as like, is the key down or is the key up? It's like, hey, where on the screen is my mouse right now? Or where on the mobile phone screen is my finger? So you'll see things like moving forward, moving right, turn rate. These are all mapped to axes. They're not mapped to input actions, because you want them to operate on a spectrum value as opposed to a binary up or down event. So for example, we see the turn rate here is mapped to the gamepad right thumbstick x-axis. Well, that's because when we move the thumbstick, we actually probably want the player to turn faster depending on how hard they've pressed that thumbstick to the right. So that's very useful, because what we can do is say, hey, like if that value is -1, then guess what? We're turning left. If the value is +1, then we're turning right as hard as we possibly can. If the value is 0, then we're not turning at all. So don't do anything. So we're not actually going to be using any axis mappings today, but if you wanted to, these are where you would find them. Instead, what we're going to do is we're going to add a couple new action mappings. So we are going to add some buttons that would let us plant a flower and destroy a flower. So go ahead and, in your brain, pick 2 keyboard keys that would work really well for you on this front. I am going to pick C to plant and X to destroy flowers, just arbitrarily. So I'm going to call those plant flower. By the way, you can create a new one by hitting the little plus button up here at the top of this action mapping. If you didn't see me do that a second ago, you're going to want to make 2 of them. So we're going to make one that's called plant flower and one that's called destroy flower, just to make those super easy to find when we search for them in a second. You'll notice right now this field is set to none. It's asking you for the key value. What key would you like this to be bound to? I'm going to type in C here, and oh, there's so many autofill options here. But what we actually probably want, let's see if we can find it. It should be under keyboard. Oh my God, there's so much VR cruft in here. Why is it like this? Okay, here we go. Under the keyboard header, you can see that the C key is all the way down here. So we want that to be C. If we wanted a modifier on that key, like, hey, maybe we want Control C to be the plant button, we could actually just check one of these boxes, and that would add like an automatic modifier on that, that key event to require that for the input action to fire. For the destroy flower button, let's make that the X key. So we're going to go down here to the keyboard header once again. We're going to find that X key. Great. We don't want any modifiers on that. And then, of course, this gets saved by default. There's no save button on this window, so you can actually just X out of it and it's automatically saved. You're good to go. So now we're going to add those input actions that we just created into our brand new player controller. So let's hook some of those up. Let's go into our tutorial player controller, and in the event graph, we're going to right click here, and we're going to type in plant flower, and your action event should come up. But guess what? We don't have any flower to plant yet. We haven't actually built the flower that we're going to plant. So for now, let's just throw a debug log on the screen. Let's just drag off from the pressed, and we'll type in print string here. And we're going to type in planting flower. I can't spell planting flower. There we go. And for the input action, what do we call it? Destroy flower? There we go. Action event destroy flower. that should come up on the press. We are going to print string to say destroying flower. And this will just help you in general when you want to validate, like, hey, is this input event actually firing? Is it doing anything? You can hook up something like a print string to it just to make sure that something is happening. So now if we hit play and we back out and we hit C, we see that message in the top left of our screen that says planting flower, planting flower. And if we hit X, we see destroying flower. So yay, guess what? Our player controller is correctly interpreting the input actions that we're getting, and the player pawn is receiving those from the controller and saying, hey, okay, what do you want me to do with them? So now we're gonna actually write the bit of logic where we make flowers appear. All right, are you ready to make some flowers? Because I'm super ready to make some flowers. Let's go to the top level content folder here, and we're gonna right click and create a new blueprint class. This blueprint class will be of type actor, and it will be called flower, of course. And I hope you're ready to put on your artist hat, because I sure am. So let's add a cylinder first. We're gonna make the stem of this flower. It's so beautiful and it's giant and chunky. We're gonna use the scale tool. And by the way, if you're trying to scale things and you're finding that like your scaling is like too much, or it's like it's going into weird chunky scales that you don't like, and you would love something that's like a little more finely grained, up here on the right, you should see this like window here. This will dictate how fast things scale. So if yours is set to say 1, then when you try and scale, it will only scale in these giant chunky 1.0 values. You probably just want to turn down that value and make it more finely grained so it can scale in smaller measurements. So let's make that like a little flower stem. Yeah, that's great. That looks like a really good flower. It's a stem. Right now it's white. I bet we can find a green material in this folder somewhere. It looks like there's this basic asset 03. I don't even know what this is. Again, if you would like to add your own special flower materials and textures, you could totally follow the materials and textures tutorial from earlier to find those online, drag them into your project, and make your flower look super pretty. I am just fishing around in the garbage for whatever materials I can find here. I do not care if my flower looks particularly good. Maybe you do. If so, kudos to you for taking pride in your work. I build shitty temp art like this all the time at work. So here's the stem. Let's rename this to stem just for clarity's sake. And then we're gonna add a couple of leaves. So let's add a new component. Let's make that like, let's do like a cube here. Okay, giant cube, I love it. We wanna scale that down probably. It's huge, so huge. Yeah. I'm actually gonna, and by the way, if your camera too, like when you try and zoom in, your camera is going nuts, you can actually hear this little whooshy camera icon, click up here. You can turn down the camera speed and just make it like not as crazy. So it's a little bit easier to control. I'm gonna make a little leaf for it. I'm gonna drag it up like this. I'm gonna rotate it a little bit. Yes, just like that. Look at that beautiful leaf. Actually, it's a little bit long. Like I'm not picky, but I'm like just that picky. Once again, that's gonna be basic acid 03. Look at that leaf, that's incredible. I should win an award for this leaf. I just copy and pasted it with Control C and Control V. I am now going to make a second leaf and just move that like right here. Maybe like a little bit lower, you know, get some real like asymmetry going on there, because nature is asymmetrical. So I learned that from an artist once. So great. Look at our beautiful leaves. This is looking real good. Okay. And for the top of this flower, I am gonna add a sphere. And this sphere is gonna be beautiful. Oh my God, it's huge. This is gonna be the top of our flower. So I'm just gonna call this flower. I'm gonna scale it down. Yeah, yes, looks great. Looking awesome. And by the way, you'll see this little white invisible sphere at the bottom here of your plant. That is just the scene component. The scene component has a little invisible white sphere attached to it just so the actor knows where, like when you're placing an invisible actor in the scene, you can still see that it's there. It doesn't show up when the game is playing, and you can actually replace it if you want to. But I just find it helpful just to know where kind of the like root or the fundamental anchor point of that actor actually is. So this one is our flower top. It's beautiful. Look at that. It's gonna be a sphere. It's gonna be best looking flower ever. Let's find a material for that flower. There are so many options in here. Arrow material. Cool. It's blue. It's shiny. I like that. That one's red. That's quite nice. Big fan of that. Ooh, bone weight material. Ooh, that's probably something that is useful if you are doing any amount of weighting of character joints in UE4, which is a thing that I don't ever do. Camera lit double-sided. Ooh, this is some kind of like camera transparency material. We're really fishing in the garbage now. I like this one though, because it's like orange and it's kind of like dark at the edges. Look at that. That's a cool looking flower. I'm gonna hit compile on this. And by the way, all of these meshes by default have collision turned on. So when we plant flowers, we're gonna get stuck inside them because they will collide with the player, which is probably not what we want. So we're just gonna go ahead and preemptively turn off collision on all of these new shapes that we just made so our flower doesn't collide with anything. In order to do that, we're gonna select piece by piece, click the stem first, scroll down here on the right, and you'll see under the collision bucket here, there's a whole bunch of settings here, but the only one that we care about is this collision preset. It's set to block all dynamic. We actually want no collision. So let's just change that to no collision. And you can do that for each of these 4 pieces. We're just gonna change them all to no collision. And if you want to, you actually can just click and then shift click to select a bunch of them at once. And you could change all of their collision presets at the exact same time. If you decided to make a much more complicated and beautiful flower, perhaps you have many petals right now that you're working with. So it will be helpful for you to shift click to select them all and then just set them all to be no collision at the same time. So that's great. Our flower should now not collide with anything. By the way, you may, all of your shapes here should be at the exact same level of the hierarchy under this default scene root. If you see anything like this, where you see like a little cube tucked under a stem or anything like that, then you might be having some struggles with trying to get the scaling just right. If you're trying to adjust the size of some of these elements or the location, you might notice that they move together. For example, if I move the stem and I have a cube parented to it, then both of them move at once. So what I would recommend is if you end up getting something weird in your hierarchy here, just click, drag it out, and make sure that it's parented to your default scene root. You want to attach it, not make it the new root. But you can just pull those things out and make sure that they are attached to that default scene root. That way, nothing should be like weirdly stuck to or scaled according to anything else in your hierarchy here. So let's save that flower. That looks good to go, like it's ready to be planted. Okay, so now what we are gonna do is back out to our player controller. And remember when we built that beautiful input action to plant a flower? Well, guess what? It's time to actually plant a flower. So we are going to drag off from here. We're gonna spawn actor from class, which is one of my favorite nodes. I use it all the time. And we are going to select flower as our class. And ooh, let's just try, so it wants to spawn transform. So what we're gonna do is we're gonna get world location. Actually, ooh, we need to get our pawn. So let's go ahead and get the controlled pawn. Again, remember how I said that player controllers are kind of like an amorphous brain that kind of has all of this logic in it but doesn't have a physical body? The pawn is your physical body in the world. The only way that you can get information about your player's location or rotation or anything else is by asking the pawn that information, because you could be possessing any number of pawns. Your pawn could be alive, it could be dead, it could be, you know, halfway across the world. All we care about as a controller is where our pawn is located right now. So let's get that controlled pawn. We're gonna get the world location of that. Get actor location. We're gonna plug that into our spawn transform. And that is looking good, but you're gonna notice a little issue with this in a second. So let's pop out here and let's press C to plant a flower. What's funny about this flower? It's floating in the air. This is a terrible flower. And the issue is that when you create a pawn, the center of that pawn, the location of that pawn in the world, is actually halfway through the pawn's capsule. It's kind of like the belly button on a person. Like the center of a person is not their feet on the floor. The center of the person is their belly button. So if we try and just spawn an object at the location of the pawn, we will spawn it at the center of its capsule. So that's no good. We probably want to spawn it on the floor. So the way that we can do that is we can get what's called the half height of the capsule, which is the thing UB4 gives us that just says, hey, if there's a capsule, give me half of that capsule's height, which is conveniently the distance from your belly button to the floor. And then we will subtract that from the height of the intended spawn location. And that will always ensure that our flowers are planted on the floor. So what we're gonna do is we're just gonna snip and get rid of this little node in the middle. We're gonna right click on this spawn transform. We're gonna split it into a location, rotation, and scale. And then I want you to right click on that spawn transform location again and split struct that pin. So now we've broken it down into its X, Y, and Z value. And transforms are really interesting because they're like 3 pieces of really chunky data smashed down into one orange pin. And there's so much information hiding in them. So we're just breaking out those pins into their smaller pieces so that we can work with them. So now if we do the exact same thing on this get actor location pin, we right click and we split struct that pin, you'll see it also breaks down into its more fundamental data pieces, X, Y, and Z. So what we want to do, we love this X, great. We love this Y as well, awesome. We don't love the Z. The Z is the height. Height is too high. Flowers floating in the air. So let's fix that. What we're going to do is we are going to, if you look at your pawn here, you'll see that it actually, this capsule that it has a name. It's called the capsule component. And this is a really, really common component that underlies a lot of pawns in UE4 because a lot of our movement code is generally driven through capsule components so that basically so that we can handle things like collisions really easily and also so that we can determine things like the speed or the size of the player. So you'll see over here that this capsule component has some properties. It has a half height, it has a radius. This is how tall and how chunky your player is. So we are going to actually get this capsule component's half height, and then we're going to subtract that from the, the belly button value, that center value of our pawn. So for this control pawn, we're going to actually cast to tutorial pawn because we know exactly what type of pawn it is, and we would like to get some specific information about this pawn that is not generic to all player pawns, it's specific to this tutorial pawn. As this tutorial pawn, we want to get capsule components. Let's see. I think we actually can just even get the half height. Let's see. No. Can we get scaled capsule half height? I don't like the scaled option though. That scares me. Let's just get the capsule component and then let's just get its half height. Here we go. So under variables shape, we should just be able to get the capsule's half height. This is getting a little cluttered. I'm gonna like bump this node out, bump this sucker down here. So now we've got the capsule half height from the capsule component from the tutorial pawn. And what we want to do is we want to, from that Z value, again, the Z value by default is the belly button of our pawn. We want to subtract half the height so that now we're getting the floor value. So drag off from this C, we're going to type the minus key, and you'll see this option comes up at the top, which is float minus float. This is how we perform a simple math operation. We have the Z float value. We want to subtract this other float from this float. It's a float minus float. And we're going to drag that capsule half height into the bottom here. And now we're going to drag out the result into our spawn transform location Z. It's looking good. Let's compile that sucker. Let's hit play. And now when we spawn, it spawns on the floor. Look at that. It's hard to tell because the floor actually has 0 shadows, but it is on the floor, believe it or not. And at this point too, you might be noticing that maybe your flower's like not as big as you thought it would be, or maybe it's too big or whatever, you got the scale wrong. You can adjust that on the flower itself. You could scale down all of those individual pieces if you wanted to, or as a little cheat, if you just want to start kind of like trying some different scale sizes and do that uniformly, you can actually change the scale of the actor that you're spawning with this spawn node right here. So for example, if I wanted it to be a little bit bigger, maybe I change this to be 3 across the board, and then compile and hit play. And now I can see what some bigger flowers look like. Those are nice. Those are some big chunky flowers. I really like the size of those. So I'm probably going to leave it at 3. And of course, the proper way to do this would be to then go back and change the actual scale of the flower and all of its pieces. Because generally, like scaling things weirdly in code outside of the main thing, if you just want the actual actor to be larger, it's not a great pattern. It's probably better to just scale the actor itself. But that's okay, because for now, we're just building something simple, and I'm not going to worry too much about the details. Okay, but so we also want to destroy flowers with the X key. So how are we going to do that? Well, so first thing, I'm going to drag this probably down here to just give it some space. But the way that we can express destroying a flower is like this. When I press the X key, as the player, I want to check, are there any flowers that are colliding with my player's body right now? And if there are, then I would like to destroy those flowers. The problem, if you actually go back and you open up our flower actor and look at it, is that we turned off all the collisions on the flower itself, and we don't really have any way to detect collision with the flower. And really actually just in general, detecting collision with the actual like pixel perfect leaves and bud of the flower is not a great pattern because it's such a small amount of space. It's not very forgiving. Generally speaking in games, if you want the player to be able to like pick up a book or pick up an object, for example, and you're using a trigger volume to detect if the player is near enough that they can do that thing, you don't want the volume to be exactly the size and shape of the object. You want it to be a little bit larger and more forgiving, because otherwise the player is going to have to like mash their face or their feet right into the object in order to actually pick it up. It's just not a very pleasant interaction. You probably want it to be the case that like as the player approaches the flower, or as they approach a book on the table, they can hit the input button to pick it up or read it or what have you. So usually if you look at volumes in games, they're actually quite a bit larger than the object itself. This is just a nice pattern for the player. So let's go ahead and let's give our flower a trigger volume, not a collider, a trigger volume that we can then use for the player to check, hey, am I overlapping with any flowers right now? If I am and I've hit the destroy key, I would like to destroy those flowers. So at the top here, we're going to add a component, and we're going to add a box collision here. I'm going to call this collider. Actually, let's be more specific. Let's call it flower collider. It's just nicer. So you'll see right away, this box is, it's fine. We could probably make it even a little bit bigger than this. Like I might make it, let's see what 50 looks like. That looks pretty good. You can also use the scale tool right here to just kind of like manually scale it if you want. I think I'm gonna make it, that looks probably about the right size to me. It's pretty forgiving, which I really like. It'll be easy to kind of delete flowers without having to like be right on top of them. So I'm probably gonna leave it at that size. All right, we're on our final little bit of code here. So let's hop back to that tutorial player controller. And when you look at this input action that we created, destroy flower, what we are going to do is try and get every flower that is overlapping with the player and delete it. How do we do that? Well, we already wrote some of the necessary code up here, so we can actually just steal that. We have this get controlled pawn, then we cast it to a tutorial pawn, we get its capsule component. That is all useful information to have. So just select and copy those 3 nodes, Control C, and then Control V to paste. Let's just pop that down here. And once we have that capsule component, we can actually drag right off from that. Because that capsule component has its own collision properties, its own collision values that come with it out of the box, we can actually get all overlapping actors. So let's type in get overlapping, and you should see this get overlapping actors, not components. Get overlapping actors is what we want. Pop that out. And you can actually select a class filter here. If you had multiple different flower classes, then maybe you wouldn't want to filter by class, but we only have one. So let's type in flower here and make sure that we're filtering by that flower class. And when we get all of these overlapping actors, well, guess what? That's going to be all the flowers that our player is overlapping with. So we just want to destroy them all. So what we're going to do then is we're going to implement a for each node, which is what we used in our last tutorial. For each loop, we don't want it with break because we just want to make sure that we delete all the flowers. We never actually want to like break out of that loop and say, just kidding, stop deleting flowers. We want to delete every single one that we find. So after this cast, let's connect this for each loop here. For each flower that we are overlapping with, we want to destroy it. So let's type destroy actor. Bam. It's a real heavy node. I love using it. I love using the destroy actor node. Like, it's so powerful. So if we compile and save that, then when we play in game, if we plant some flowers and then we hit X on those flowers, oh, they go away. So here we go. We're planting flowers. We're planting flowers. And then let's hit X. There we go. We just cleared some flowers away. We are truly master gardeners. And we can both create life and bring death. Haha. That's really dark. Sorry. Okay, so what have we learned? We've learned how to use input actions to spawn actors. We've learned how to use input actions to destroy actors. And we've learned how to place things at the player's feet based off of an input event. So this really is the fundamental starting point for a lot of things that we're going to do with input in future tutorials. We're going to learn some more intelligent things and some more valuable methods of doing this type of thing to build more advanced gameplay systems in the future. But this is a really great start for now. So something I'm noticing is that after a lot of these videos, people often have questions about something that they ran into in the video, a problem that they encountered. So what I'm going to start doing is trying to keep the description under the video updated for all of my videos if there are any common issues that people are running into, just so I'm not responding to each person individually. So please do check the video if you ran into any problems in this tutorial, and if you see that your question hasn't been answered there, then go ahead and ask and I'll try and add it to that section. What I'm also going to do today is add an optional homework assignment that you can complete between this lesson and the next lesson if you want to continue learning more about input events using just the stuff that you learned today. It should be very slight extensions of the stuff that you learned, but I have confidence that you can figure it out. And I think even now, just with this amount of information, there's some really cool things that you can try. As always, happy learning. And in our next lesson, we're going to be learning about something called raycasts and how you can use raycasts to do more intelligent and important things with input in your game. I will see you next time, and I hope you have a lovely week. Thanks for watching.